Welcome to iLecture Online, and now we're going to look at some new type of lens called the diverging lens. So we're still in the set where we talk about mirrors and lenses, and especially thin lenses. But the diverging lens is something unique because in this case, when you have lines that are parallel to the normal that shine through a diverging lens, that will of course diverge the rays of light, but the way they will diverge is as if they came from the focal point in front of the lens. So anytime a ray comes through, just draw a line from there to where the ray goes to the lens, and then the ray will then continue along that path, hence the name the diverging lens. So if we now place an object in front of that lens, and for the first example I put the object beyond the focal point of the lens, in front of the lens, where will the image appear? And again, we're going to use our techniques, and here's my blue pen, the techniques to figure out where the image will be. We draw our first ray from the top of the object, again parallel to the normal, just like we've done with all the other lenses. And then we realize that the ray will diverge as if it came from the focal point in front of the lens here. Like so. So this is ray number one. Ray number two is through the focal point, but since this is a diverging lens, the focal length is a negative focal length, therefore the focal length is a negative 25 centimeters. So the focal point of interest would be the one back here. So we want to try to draw a line, a ray line from here to this focal point right there. And when we do that, of course, we get to the lens, and instead of continuing to the focal point, it will diverge, and that will continue then parallel to the normal beyond that point. And that will be ray number two. And of course, we need a little eyeball right here because the observer will be on the other side of the lens. And looking back, seeing those two rays diverging, obviously they're not coming together forming an image on the right side of the lens, but the brain kicks into action and says, oh, I know where those rays are coming from. The number one is coming from over here, number two is coming from over here, and where those two lines meet right there, that's where the brain will put an image. And so the image will appear right over there. Now, let's go ahead and use our equations to figure out where the exact location of the image is. Again, we use the same equation, S prime, that's the distance to the image, is equal to S times F, that's the distance to the object and the focal length, divided by S minus F. And plug in the numbers that we have. Let's see here, S is 50 centimeters, and the F is a minus 25 centimeters. Remember, for a diverging lens, the focal length is negative, divided by 50 minus a minus 25. And so this will give us, let's see, 1,250. That would be a minus, divided by 50 minus minus 25 would be a positive 75. And, let me grab my calculator, what is that equal to? So we have 1,250 divided by 75. And yes, indeed, that would be a minus 16.7 centimeters. And so you can see here, if the focal point is 25 centimeters away from the lens, you can see that the image is about that distance. And so we found S prime here, S prime, of course, is going to be a negative 16.7 centimeters. Negative, of course, means that it's in front of the lens, and therefore that makes that a virtual image. So I is virtual, because it's in front of the lens, it's not a real image. And of course, that's indicated by the negative sign in front of the image distance. Now, the magnification, M, is equal to minus S prime over S. So it'll be minus a minus 16.7 divided by S, which is 50. And that looks like it's about 1/3. Yes, it is. So that would be a positive 1/3. 1/3 means that it's 1/3 the size of the object. And the fact that it's positive means that it's in the same orientation as the object, therefore it is upright. And that's how we find the image with a diverging lens. Okay, we're going to try another example, now placing the object inside the focal point to see if that makes any difference for a diverging lens. So that will be on the next video.